Okay guys, today we're going to finally see why we've learned factoring and what the point of that is. We've been talking about parabolas and finding the graphs of parabolas, which are the, the picture that you get when you plot the points for a quadratic equation or quadratic function. We found the max and min of a parabola, and we talked about roots last time. Well, factoring is a way of finding the roots of a quadratic equation whose graph would be a parabola. So before we get into that, I want to start with by saying we're going to be talking about equations today. So you'll see equal signs in the things that we need to solve today. And so we should start with something called the zero product property. It may seem obvious, but it's a necessary property here for solving quadratic equations. It says that anything multiplied by multiplied together to get zero must be one of them or both of them must be zero. So anything multiplied to zero becomes zero. That's true. But what it's saying is that either one factor, this one, or the other factor, or both of them must equal zero. So what we'll be doing is taking things in factored form. We know how to get it into this form, x plus 1 times x minus 3, set it equal to 0, and then by the zero product property, set each factor equal to 0. So either x plus 1 equals 0 or x minus 3 equals 0. Both of these are pretty easy to solve. We can subtract 1 from each side, so x equals negative 1 is a solution to that equation. If I were to take negative 1 and plug it in up here, for x, this whole term right here would equal 0. And 0 times, I don't care what this one is, this one would actually be negative 1 minus 3. We're plugging in negative 1 here, plugging in negative 1 here. Negative 1 minus 3 is negative 4, and 0 times negative 4 is also 0. So if we have an equation where two things are being multiplied to equal 0, then either one or both of them have to have equaled 0. So here x minus 3 equals 0. If I add 3 to each side, I have x equals 3. And so my solutions to the quadratic equation are x equals negative 1 or x equals 3. So if I were to graph this, I know it's a parabola, it's facing upward, and it has roots at negative 1. I'll put that in red. Passes through the x-axis at negative 1 and also at positive 3. So there are roots at negative 1 and positive 3, and then it something like this. We don't know how far down it goes at this point, but we know what its roots are, where it crosses through the x-axis. So that's what we're doing with factoring. Is factoring helps us to find these roots when you go to graph the parabola. Alright, so here's using the zero product property. It says, what are the solutions? These are already in factored form, so we're going to do the same thing we just did on the previous page. Either 4x plus 1 equals 0, or x minus 2 equals 0. So those are my two equations that I need to solve. So this one over here, the 4x plus 1, here, 4x plus 1, to apologize, there goes my board again, equals 0, or x minus 2 equals 0. This one I'm going to subtract 1 from each side. So I have 4x equals negative 1. And just move this down a little bit here. Next step is to solve for x, so I'm going to divide each side by 4. So this is 4x equals negative 1. And when I divide by 4, I get my solution. X equals negative 1/4. And over here, if I add 2 to each side, I get x equals 2. And so I'll circle my two solutions. If I were to graph that parabola, those would be the roots. Move on to the next one here. We have 2x plus 3 times x minus 4 equals 0. By the zero product property, either 2x plus 3 equals 0 or x minus 4 equals 0. This one on the left, I would subtract 3 from each side. So 2x equals negative 3. And then finally, divide each side by 2. So x equals negative 3 over 2. So one of my solutions, we'll go ahead and circle that or box it. The other one, if I add 4 to each side, I get x equals 4, and that is my other solution. So the goal is to get our quadratic equation into factored form like we did in problem 1, like it's given to us in problem 1. So that's our goal here. And so when it says solve by factoring, we're going to use the methods Xbox or guess and check, the methods we've learned before, to factor first. So here on problem 2 we have what's called a simple quadratic. That means all I need to do is draw my x. I don't need the box with it. I'm looking for factors of the last number here, 15. And actually, if you wanted to, you could apply the techniques we've been learning. There's actually a 1 in front of the x squared. If you do your little umbrella here, 1 times 15 is still 15. So we are only looking for factors of the last number 15 that add to equal 8. Pretty easy thing to do. There aren't too many factors of 15. The only factors of 15 that I know of are 1 and 15 and 3 and 5. And the only two that add up to equal 8 would be the 3 and the 5. And so because this is a simple quadratic, it has a 1 in front of the x squared, or in a's place. We call that number in front of the squared term a. We can easily translate this into two factors. X plus 3 times x plus 5 equals 0. And so by the zero product property, we can set each factor equal to 0. X plus 3 equals 0, or x plus 5 equals 0. And by subtracting 3 from each side in the first factor, we see that we get negative 3 as our solution. X equals negative 3 is one solution. Or by subtracting 5 on each side in this one, we get x equals negative 5. And so my two solutions are negative 3 and negative 5. As a matter of fact, it might be helpful to see that we can check these in here. Let me move that back up. It says x squared plus 8x plus 15 equals 0. If this truly is a solution right here at negative 3, I should be able to take negative 3, plug it in for x, so negative 3 squared plus 8 times negative 3 plus 15 should equal 0. Let's just check that. Negative 3 squared is 9, minus 24, 8 times negative 3 is 24, plus 15. Does that truly equal 0? Well, 9 minus 24 is negative 15, and negative 15 plus 15 is, in fact, 0, so it checks out. And if you were to do the same thing with the negative 5, if you plug negative 5 in for x, you would find the same thing would happen. You would get 0 equals 0. So when we find solutions to a quadratic equation, we're finding the roots, or also known as the zeros. It's what makes the equation equal to 0. All right, I have one more example here. Leave that there for a moment so you can finish copying down the check. You don't need to do this, but just to show you, if I plug in negative 5 and square it, plus 8 times negative 5 plus 15, does that truly equal 0 as well? Well, 25 minus 40 plus 15. 25 minus 40 is also negative 15, and negative 15 plus 15 is 0. And so that one also checks out. So if you'd like to, you could copy down those checks there. If we've done it correctly, if we factored correctly, found the right solutions, then when I plug it in, it should equal 0. All right, well, we have one more quadratic equation to solve, and this is about as hard as they get. We're going to have to use the x box on this to factor. Before we can go about factoring this one, we need to make it look like the problem above. If you look up here at the problem above, you'll see that up here x squared plus 8x plus 15 actually equals 0 there. And in problem 3, it is not equal to 0, not yet. But we can go ahead and subtract 18 from each side. So it looks like this. Subtract 18 here, subtract 18 here. Now, 18 is not a like term with 21x or with 4x squared. So I have 4x squared minus 21x minus 18 must equal 0. You can't combine any of those terms. They're not like terms. So therefore, I'm going to set up my quadratic equation in standard form, we call that. Everything's set equal to 0. I'm going to draw my x. I'll go ahead and draw my box. I'm going to need the box as well to get my factors. We're looking for factors of 4 times negative 18, which is 4 times 10 would be 40. 4 times 8 is 32. 40 plus 32 is 72. So that's factors of negative 72 that add to equal negative 21. Well, there could be a lot of factors of 72. Let's go ahead and start listing them and see if we can find a couple of them that are 21 apart. So we have factors of 72. 1 and 72, 2 and 36. Does 3 go into 72? Looks like it. The digits 7 plus 2 add up to 9, which can be divided by 3. So 3 will go into 72. It goes into 7 twice with 1 left over, and it goes into 12 4 times. So 24 times. Oops. I think I found it. 3 and 24 are the two factors that are 21 apart. So I'm going to stop right there, list my 3 and 24, and then decide which one gets the negative sign. So I need these to multiply to equal negative 72, but add to equal negative 21. So the bigger of these two has to take the negative sign. So now what I have is, in my box, I have 4x squared. I have a 3x, a negative 24x, and the last term on there is the negative 18. Those are the 4 terms of my quadratic. Then I go ahead and factor out the greatest common factor from the first row. The greatest common factor between 4x squared and 3x is x. And the greatest common factor in the second row between negative 24x and negative 18 is a 6. Now, because there's a negative in the box right here, next to the edge, I'm going to pull out a negative 6. You'll see in just a minute when I check it why that's necessary. Now, going this way in the column, so we're going to go looking in this column here. What's the greatest common factor between 4x squared and negative 24x? That would be a 4x. Just check here, x times 4x is 4x squared. Negative 6 times 4x is negative 24x. So I can check by multiplication. The greatest common factor in this column right here between the 3x and negative 18 is positive 3. And then I can check 3 times x is 3x. 3 times negative 6 is negative 18. So my factors are 4x plus 3 and x minus 6. Set those equal to 0. So then the final step, once I have factored them, that's the hard work, which you've already learned how to do. The zero product property just says, go ahead now and take 4x plus 3, set it equal to 0, or x minus 6 equals 0. So 4x plus 3 equals 0. I subtract 3 from each side. 4x equals negative 3. Then divide by 4 on each side. So x equals negative 3/4 is one of my solutions. We'll circle it. And the other one over here, if the x minus 6 equals 0, let's move this over just real quickly. Those are my factors. Okay, so add 6 to each side, and x equals 6 is my other solution. Circle it. So if you plug those into the original equation up here, leave it there for a moment, plugged in 6 to this original equation right up here. Whoops. right up there, if you plugged in 6 or you plugged in -3/4, you would get the left-hand side would equal 18 to equal that original equation. All right, well, that's it for the notes for 9-4.